Hi everyone, I'm Farhad. Matan and I are leading the Angular Dart effort at Google. And we're very happy to be with you today to share what we've been working on inside Angular Dart. And we're going to introduce today some new tools to help you build great web applications. And Angular Dart, these are the three big pillars that we think of when we're working on Angular Dart. Basically, any new feature we add or when we make changes in the APIs, we try to make sure we have a perfect balance between these three items. So on the productivity side, we started doing surveys inside Google. Now our customer base, the number of developers are substantial enough, so we're getting a lot of data on productivity inside Google. Performance-wise, we have now hundreds of benchmarks on components and actual apps running in production. So if that material button gets, just 5% slower somehow because we made a change. We immediately get an alert. Basically, it'll say this exact change, you affected these benchmarks across the stack, and then we either roll back or look at the issue and fix it. So this allows our teams to have a predictable and stable framework under them. Because we want to make sure once they ship these into production, the apps stay stable and they keep on running at high performance. So about stability, since last summer, we've been working with these large Google teams to get Angular Dart into production. And at this point, we have monitored, talked to a lot of these teams, and looked at the problems they were having in terms of productivity, worked through some of the APIs, made them better. And as Dan mentioned, basically, we think we're ready for you to start building production apps today. So we're happy to release it today. This morning, we published the new package. So you can update your pub spec, remove that beta from it, and start using it today.
So how many people here have written a web application before in Dart? Can I get a show of hands? How many written in Angular Dart? Pretty good, actually. This currently is our workflow for Angular Dart. I think it's actually one of the best workflows for a web app. This is how easy it is to get started. You get WebStorm or your favorite IDE. You write a little bit of code, you hit pub serve, and you refresh. There's no other setup, no other dependencies, nothing else. It's actually really this easy. You can do it in 5 seconds. And I think this is an awesome experience for Angular Dart.
So for those of you who are new to Angular, people love Angular for its ease of use and productivity. Basically, your HTML and CSS is front and center. So you just simply edit an HTML file. And then you write a Dart class, which becomes your component. And then you wire up your template. So it's a very easy model to get started with. And this is a typical Dart app. Basically, you just import the library, set up your component. In this case, I have a single property I'm binding to. And then you bootstrap your app, and you're up and running. So people love how easy it is to get started in Angular Dart and start building web applications. So Angular Dart is also very deep. Once your application starts growing, to give it better structure, Angular Dart provides dependency injection. So you can start moving some of the services, some of the data layers out of your views. And you can simply inject these services into your components. And so that's on the component side. And on the template side, it provides a system called directives, where you can basically define behaviors. You can extend the language of the templates. So you can create new elements that expand the DSL and allow you to build really powerful libraries that you can reuse across your app. And injection is real easy. You just create a Dart class, my service, put @injectable on it, and it's ready for use. Now I can take that my service and just inject it in my constructor on the main component. This makes it very easy to build tests. Matan later on will be showing you how much nicer it is now to test Angular Dart applications. And for directives, essentially you define a selector. In this case, it could be autofocus. So whenever your view gets created, it will focus on the element we have this directive on.
So a big part of why we actually like Angular and why Angular likes Dart, we are really trying to use all of those great core library features that Dan and Casper talked about. So Angular Dart is all about streams, zones, futures, the collection library. We're not inventing new things. If you're comfortable writing frameworks or apps in Dart HTML, and we saw last night that a lot of people wrote their own frameworks with Dart HTML, we're using the exact same thing, right? So it's streams, it's futures, it's all these core libraries. You can open the code. It's not something special. So it's really exciting.
Mm-hmm. And the big change in Angular 2.0 is that we're compiling templates now. And compiling templates has very good properties. So the first one is faster DOM construction. So traditionally, the way we constructed DOM in Angular 1 and before is we would essentially take the template and then build it inside the DOM, and then we would clone that tree of DOM nodes at runtime, right? But of course, since we have bindings and attributes on those DOM nodes, we would have to go back, get the references of each of those DOM elements, and then update the attributes. What compiled templates lets us do is we can actually write code as if a human wrote it. So we made some of these changes over the past 2-3 months. If you look at the generated template.dart code, you'll see it writing document.create element, and it will put the tag name in there. So it's very readable now, the way we are generating these templates. It is powered by the Dart HTML library underneath, so it's very familiar. Whenever you want to debug a component, you can simply go into the template Dart file, and you can put a breakpoint, and it will look familiar to you. The other property compiled templates have is we started typing the members we have in those template.dart files. If you open it up today, if you use an input element and you have a value property on it, the input element is now completely typed in the Dart version. So if you have value property, it'll just set the value. If you try to use it on a div element, at compile time, it will say the div element class doesn't contain the property value. So at compile time, we can do these checks. The same thing with your expressions. If you use a binding expression and we compile it into Dart code, at compile time, you're going to get errors. So the other cool thing about compiling is we get zero-cost abstractions. So traditionally, Angular had done all these things at runtime. For example, at runtime, it would check, am I running in debug mode or am I running in release mode? And it would select debug or release versions of those classes dynamically at runtime. Of course,
imagine like hundreds of if statements, like every single part of the code, if debug this, everywhere throughout your code.
Yeah, yeah. And what we're able to do is we're able to essentially now target the exact release mode or debug and generate different code. If you go to your pub spec and change code gen mode to release or debug and look at the template again, you'll see how much smaller the release versions are. And in the debug versions, it's adding more debug info for you. So if anything goes wrong in your code, you get better stack traces. Another good example for this is because we're compiling, at compile time, we know that a template reference or an element reference is actually just a field on the view. So we can directly pass it into the constructor. At runtime, we don't have to look up in the injector, look up in a map, and get these references. So we can make injection faster, because at compile time, we already know about these abstractions. So a lesser known attribute of compile templates is actually security. So we're not doing any evals anymore at runtime. So we take your expressions, we compile them into Dart code, and now you can't inject another function in there or try to attack the applications. So this has very good security properties. Our security team at Google loves that we're now compiling these templates. So, of course, compiled templates come at a cost, and the cost is code size. We're generating more code. You know, the traditional take an HTML snippet, that string actually compresses really, really well. But now we're generating Dart code. So we've started working hard on this code size issue, and this is a graph from one of our code size benchmarks. And this one dropped from 1.56 megabytes to under a meg now. So we got 40% less Dart code generated now without changing anything in Angular. And we're not done yet. There are some big gains to be made still on the code size side. So how did we do it? How did we drop 40%? Well, first of all, as you know, Angular Dart is a separate repo now from the TypeScript version. So we started using idiomatic Dart code when we generate this compiled code. So one of the examples are, we removed this dot from all of the code generation, and that gave us 8%. So that means when you're writing code today, you're typing 8% less code because you don't have to do this dot everywhere in Dart. It's wonderful. And all the other properties that we love about Dart, the terseness of it, as Dan mentioned in his talk, we started using them in the templates itself. So that reduced the cost. And we also started removing all the dynamic calls. So when Dart2.js compiles it to JavaScript, it doesn't have to check the classes at runtime. It generates much, much tighter and more efficient JavaScript code. And as I mentioned before, we started removing abstraction layers. So to us, Angular Dart is perfect for the web. And our main focus is actually web development. So we don't have to have extra layers for mobile native bindings and things like that. So tomorrow's talk is going to show you a great framework to do mobile development. So in Angular Dart, we're now able to take out a lot of layers that were in between to support to turn Angular more into a platform. We are concentrated completely on the web to create great desktop and mobile web applications. Another change we did is white space compression. Some of you might be familiar with the HTML spec, where if you have two inline blocks, it actually matters whether you have space in between them or not. The browser is going to basically lay out your HTML slightly differently. But very few people use this property. And it's one of the reasons other frameworks haven't done white space compression. Otherwise, we'd have a tool already that would be compressing your HTML. But you can't tell this at compile time, right? Because it's CSS. You don't know which CSS is going to apply. So when you're compressing the white space, you can't really tell. But with the latest release, we're giving you a new component property. It's called preserve whitespace. If you turn this to false, it will basically remove all new lines, all spaces inside your templates. And it's quite amazing how much you can save. On our material input component, we went from 40 DOM nodes down to 17. There was so much white space in it. Basically, every single line, you have that /new line at the end. Believe it or not, that actually generates a text node behind the scenes. So that's code size. And going forward for performance, we're primarily concentrating on two things. One, strongly typing everything across Angular. So a lot of the compiled code has started using this. And the nice thing is we don't have to change the public APIs. So most of this work is under the hood. We're now making Angular faster and smaller without affecting the public APIs.
And Leaf happier.
Yes.
Very important.
So the second big change, which is our surprise for you today, is we're introducing a new way of doing change detection in Angular today. So instead of dirty checking, we're introducing a mixing class called component state. So traditionally, this is what goes on behind the scenes. If you create a template today, you have a binding. And we create this code that basically checks the new value against the old value. And if there was a change, it updates your template. However, all the Angular components, by default, are marked as check me always. So if any event happens in the system, it will check all your components. And if there's a change, it will mark the children dirty if they have property changes. So there's a lot going on behind the scenes to make the zone turn actually update the templates. So I have a demo here of that shows you how this works in practice. So I have a material table that's using default change detection. And as you see, the table's scrolling. As it's scrolling, we're generating new rows on the fly as the user is scrolling on demand. And if you watch the frame rate, it started dropping from 60 FPS and keeps on dropping. So this is a real production table. So probably 90% of this code, one of the architects is back there that works on the table. So this is the actual production table we use. And to support all these feature teams inside Google, we had to build a really powerful table. Every single cell here is actually an Angular component. Because inside apps, people want, you don't have a fixed set of columns. The order isn't determined. Depending on who logs on to your application, you might want to show a completely different table. And so here, what we're doing is the table is completely built. So when I scroll around, I expect actually nothing to happen.
But with no changes, yeah.
Yeah. So, but if you look at the CPU, it's maxed out to 100%. And if you look at one of these timelines, it should be very familiar to you who built very large apps. So it's basically doing change detection. It's going through the whole tree and doing change detection, although the table at this point is doing nothing. It's not mutating DOM. We're just handling a scroll event. So what we're introducing today is basically an easier way to do on-push change detection. So one of the original designers, Viktor Savkin, designed on-push. And over the past 3 months, we've been working on a way to make this much, much easier for you. So basically, you have a component state mixin, and you say, as a component, I know when my state changes. So Angular, please don't keep on calling me. I'm going to let you know when I want my template updated. So what you do is you do a set state call, and you pass a closure that actually mutates the state. And as soon as you tell Angular set state, it will come back and basically change detect just that component, that single component that changed, and then it will update your templates. And if you have something asynchronous, like your RPC completing, You can do the same thing. You can just say set state and update model. So I took the exact same table, changed about 4 classes, and mixed in component state. And on each input, I put a set state in there. And this is the result. Basically, we're generating about, let's say, 10 columns, 1,000 rows. Each cell has actually 2 components, to stress it a little bit. So we have about 20,000 Angular components being created right now. And we get consistently 60 FPS. So what's even nicer is, now if I go and capture a timeline and scroll the table around, it runs some code in request animation frame. If you have any sticky headers on top, it will actually align them. As you see, the CPU is totally idle. This is the type of timeline you want. It's like these thin hairlines, 16.7 milliseconds, you know. Most of that is completely idle and empty. So you've got plenty of space there to run your code. And we're just getting started on making Angular Dart faster. The nice thing is, now that we have stable APIs and all these changes in, we can keep on improving it. And with that, I'll turn to Matan, and he'll talk about how we do testing with Angular Dart.
All right, so we have a fast table, we have all the other fun stuff. One of the things that we developed internally and we never had an external version was an Angular Dart specific test bed for testing Angular Dart components for big applications. There was some testing code, it worked for some cases, but it was doing a lot of fake things behind the scenes. It was creating fake views, and you had to kind of hook everything up together. So we're using a new model. We call it NG Testbed, how we're open sourcing it today. And writing a test with NG Testbed is actually just like writing a Dart test. This is using package test, and you're creating a strongly typed component called NG Testbed, which is of type, in this case, Markdown component. So you're actually going to test your Markdown component. Again, this is all typed. You're going to create a fixture. A fixture is a running Angular application. And when that component is created, we're going to call the text setter. This is like a property, and assign it this Markdown value. Next line, we're just going to expect that the inner HTML of that template has, a bolded hello world. There's no special code behind the scenes. This reads just like normal Dart code. And on top of it, this is entirely using generated code. This is an AOT test. We no longer need to use interpretive tests. This is all using the same production code paths. That's pretty easy for a simple test. But when you write more complicated views, you don't want to keep checking, oh, did the HTML change a little bit in this way or whatnot. So we have something we use internally at Google called PageLoader, which is also open source, where you can actually model your templates as Dart classes. It's kind of like going the inverse. In Angular, you create components that create HTML. Now we're going to go the other way. So this is writing a page object. There's a code lab actually now uploaded in Angular 2 examples showing this exact code. But for this case, you're having a selection box. You might have a selected name right up here and a confirm button. Then when you click on it, you want to confirm this is the person. Maybe this is a reservation system. And on the right side is our Dart class. So again, it's a pretty plain Dart class. It's annotated a little bit. It's saying that we have a selection class called selection, and we have a tag called button, which is the confirm button. And we have 2 publicly part of the API, which is our selected name and the ability to click the confirm button. So this is your API. If somebody else uses your component, they can actually use this test infrastructure. They don't have to write their own. And then using a page object. Again, you use the same NG testbed. I have a little bit of boilerplate at the top just to show more about how it works, but we can hide this for sure. And we're creating what's called a new HTML page loader. We're wrapping it around our testbed fixture, and then we're adding a little bit of code to say when something asynchronous happens, like you click on something, you type into an input box, how do we wait for Angular to say everything is done, now run the next line of your test? So it works exactly the same. You load an instance of your page object, not the component, but the page object, and you actually interact with the component the same way a user would through the DOM. So here we're going to wait that the selection was Joe user, and then we're going to click the confirm button. I have a demo. We're going to flip over. We're going to hope everything actually works. Because demos always work at Code Labs. Let's see. I'm using the community contributed Visual Studio Code plugin for Dart. Thank you so much. And we actually have here two tests. We have a test of your Markdown component, kind of what you saw before, a very similar thing.
Are you able to see?
Do you want to zoom
Maybe
in?
zoom in a
Yeah,
bit?
yeah. Is that better?
Cool.
Okay, so we're going to test our Markdown component, and we're going to say when we assign the hello world, we want to see hello world. I'm going to go ahead and pub serve this. So this is actually my app. I wrote a little GitHub viewer for Angular Dart just to be able to demo this. And it uses the GitHub API, and it shows all of the open issues in Angular Dart. It looks like a couple were added. Whoops.
Last night.
And this, you can click around here, and you can see the markdown rendered of the issues, and you can kind of go around. This is a simple GitHub viewer. How do you test this is the real question, right? Like, this is a pretty complicated application. It makes network calls. It renders with lots of components. This is actually the same way I showed before. So we're going to go over here. This is my, again, pub serve. And this isn't super exciting, but you see the words hello world and they're bold. You actually see the result of your test in Edgy Testbed. You can add breakpoints and see incremental work done. If you open the console right now, you'll see that all tests passed. This is using package test. Let's do a more fun one. This is actually an end-to-end test of the entire app. This loads with a fake GitHub service and actually clicks around on the screen and is doing assertions that everything actually worked. I'll do one more time. It's kind of fast. Too fast. Sorry, Prod. So we're clicking around. And if you open your console again, all tests pass. And I'm running assertions to make sure that none of my code breaks. Maybe the GitHub API chain, something like that. You can also run this with pub run test on Travis, for example. So we're going to pub serve just the test folder.
So what's awesome is typically when we try to make a change in Angular Dart, we're running about 70,000 targets right now. So each of those targets have, 1 to 10 tests. So we have a huge number of these in use now inside Google 3. So that helps a lot with our stability. When we make a change, we're very confident that it won't break your code and it won't break any of our own production apps.
So we just passed two tests. These, again, are using the code gen mode. This is using PubServe to actually do code generation. This runs on Travis. You can now validate that your tests keep running the same way they run in production. You don't have to write really complicated WebDriver tests, but you can. Please.
Yes, so Dart for web, we think Angular Dart is a great solution. Please check it out. Give us feedback on how we can further improve it. And we're looking forward to seeing what you build with it. If you have any questions on Angular Dart, we'll be around for the next 2 days. Please come and talk to us. Thank you.
Thank you.